All right. Well, welcome everybody. We're very excited for you to be joining us today. Welcome to Solar System Exploration. My name is Jackie. I am an Academy educator at the California Academy of Sciences, and I have my friend Josh.
Hi, everybody.
And we're really excited to be exploring along with you today. Now, as a reminder, today we are on YouTube Live, so we won't be able to get your comments. However, we do have some links that we will be able to share with you in the middle of our program where we're going to be able to explore, and you can use that to let us know some of your ideas, some of your predictions, and some of your observations. And thank you so much for everybody who has sent us some of that information already. We actually, Josh, got a lot of people already using that Mentimeter to explore our night sky.
That's
Um,
awful.
and think about our daytime sky as well. So I want to kind of share some of the things that some friends have already shared out with us today. So looking at a nighttime sky looks like a lot of people are talking about seeing planets and
Oh, cool.
moons and stars.
Absolutely. I can see planets and moon front and center. There's constellations in there, too. A whole lot of blackness. I suppose that's true of our nighttime sky as well. Blueness in the daytime sky.
Exactly. Well, I actually did ask everybody to share out as well. What can you see in the daytime sky? And
Oh,
that's one of the
nice.
big things is a blue sky.
Clouds. That's all too often the case in San Francisco and the whole Bay Area is you get to see clouds. But from other places, you get to see some pretty beautiful stuff. I see some birds, some clouds, stars in the daytime sky. I guess if you knew exactly where to look at special times, you certainly could see some stars. You can see one star for sure, our sun, but a lot of people don't count that when they say stars.
Well, speaking of our sun, I know today we are going to be diving into looking at the sun and the moon and our sky in general here on planet Earth. So I'm going to go ahead and turn it over to you, Josh, to explore our sky right now.
Sounds pretty good. So I'm using a very cool program called Stellarium. You can see the name way up here in the corner. And if anyone wants to check it out, you are more than welcome to. This is a free computer program and one that's really fun, really easy to use. But I'm using it to show us the sky as it would appear from Golden Gate Park. How do we know it's Golden Gate Park? You can see our museum right over here. I miss it. I get to go there sometimes, but I can't wait till we have everybody returning all the time and we get to reopen our planetarium. But when we look at the sky around Golden Gate Park, you can see our sun right here. And we can actually see in our daytime sky something that people often don't expect to see. Right over there is our moon. Now, when I walked the dog this morning, the moon was much higher up. By now, it's a little lower in the sky. But when we look at our sun and our moon, they're changing positions. Our sun is getting higher, the moon is getting lower. So I want to see if you could maybe extend your brain out, think about this for a minute, and make a prediction about where you think the sun will be traveling. Where do you think the moon travels? If we look at this view of our sky around us, which direction do you think the sun is going to go? So try this out with your finger. See if you can figure out which direction the sun will travel. Do you think it's going to go this way, same direction my mouse is traveling? Maybe this way, over this way? Lots of possibilities. Could go pretty much any direction. So think about that for a minute. And then I'm going to use our computer program to make time fast forward. And when I do, you'll be able to keep track of how fast it's going right here. You can see which direction the sun travels in. But if you haven't already, make a prediction, maybe on your computer screen, point which direction you think the sun's going to go. Are you ready? 3, 2, 1. Ooh, did you guess right? Now I'm going to stop time. Let's go check in with our friend the moon. Uh-oh, what happened?
Well, it
Our
looks like
moon's
it kind of
now,
went down and below the horizon there, Josh.
it's hiding behind our friend the DeYoung, but in a couple seconds it'll be below the horizon, and that's okay. The moon sets, our sun's getting higher and higher. We're getting closer to midday, And eventually, we're going to see our sun start to get lower and lower in the sky. So, is this what you expected to happen?
Well, I knew the sun kind of came up at one part of the sky and kind of went down on the other and then kind of came down again. So it's kind of what I expected, but I think it took a little bit longer than I expected, at least for right now.
So, we're in an interesting time of year where our seasons are changing. We just went into our autumn season, and that means you may have noticed, our days are getting shorter and shorter, our nights are getting longer and longer. We're going to fast forward time again to see some planets and the stars go by. We saw our sun set over in this direction next to our letter W and our letters SW. So this would be sort of west by southwest. If we want to see our sun rise, we got to turn our eyes over to the eastern sky. We can see our moon come up, and then in a little while, we should see our sunrise. Now, this is what the sky will look like late tonight, early tomorrow morning at this point, I guess, about 1 o'clock in the morning. So hopefully everybody's warm and in their beds. But eventually we should see our sun come up. And when it does, I want you to pay attention to where our sun is rising. I'll pause time when we can see it. Boom, I think right there. Okay, so our sun came up at around, let's call it 7:30, close enough, between southeast and east. So let's try this out. If we were to look at our sun during a different season, we might see it in a different place and a different time. So at 7:30, in about 1, 2, 3 months, where's our sun? Well, if you look for that glow, you can see it's brightest around here, but at 7:25, almost 7:30, it's not up yet. We have to wait a little longer for the sun to actually climb above the horizon. By the time our sun is really above the horizon, it'll be almost 8 o'clock. Now, this is what our sun would look like around, let's call it February. Yeah, February. If we were to wait a few more months, let's say 3 more months, 1, 2, 3, by 8 o'clock, the sun is very high. You may have noticed it actually changed the direction it's rising in. It's rising much closer to east, not between east and southeast anymore. So this is what our sun would look like in May. Let's try 3 more months. 1, 2, 3. The sun's starting to travel back this direction, and it's a little lower in the sky. That means we are getting out from our spring months into maybe late summer. And then if we go a little bit more, 1, 2, 3, back to November where we are now, you can see our sun's rising later, and it's rising farther to the south, again, closer to southeast. So over the course of a year, that's what we expect to see over and over again. The sun changes the place that it rises, it changes the place that it would set too. Okay, so we talked a lot about our sun. We've gone almost a year into the future. So I'm going to take us to now, go back 1 full year to 11, too far, today, the 6th. And let's see what our sky looks like at the present time. So what time is it? It's about 10:30. Yeah, call that pretty good. Okay, so here's our sky once again created as we would be seeing it from San Francisco and looking up at our daytime sky. Where was our moon? It was just about to set. So let's check this out. When you look at our moon, what does it look like to you? What kind of shape would you say that has?
So, Josh, a lot of our friends were noticing that a couple of days ago that it was more full, but now it definitely is not. In fact, we had some friends send in their moon observations that I would love to share for just a
Absolutely.
second.
Let's check it out. Oh, cool. Excellent moon drawings.
Yeah, and it looks like there was maybe some cloudy nights or days as well,
Yeah, Bay Area astronomy has that happen a lot.
and
So
other places.
yeah. So looking around here, I can see a very full moon. This looks like it was done a couple nights ago. Excellent. So we had a very full moon around the end of October, beginning of November. But now that we're moving into kind of the first week of November, it's getting a little bit harder to see the moon as a full circle. So this is what we call a gibbous moon because it's got kind of a good sized lump to it, not perfectly flat side. And over the next few days, it's going to change its position in the sky and it's actually going to change the shape we see. So let's try that out. I'm going to jump one day into the future. Remember what this moon looks like. And then one day in the future, our moon disappeared. No more moon. Actually, that's not true. Our moon's going to travel closer to the sun. And as it does, you'll notice now it's got a very flat side to it. So this is what I might call a first quarter moon. We went from the very edge of a gibbous moon to a third quarter moon, because this is 3/4 of the way through its motion. Okay, and now we're going to go back again, zooming back. And we're going to fast forward one more day. Again, the moon's in a different spot. Let's try 2 more days. And now let's zoom in. Do you think it's still going to look like a third quarter? Nice flat side? No, it's starting to look a little curved now. It's actually starting to curve the other direction. So let's try 2 more days after that. Are you ready?
Well, let's go ahead and pause here for a second, Josh, and see what other friends might predict themselves. So instead of 2 days, let's go ahead and do 3 days.
Can do.
So what do you all think? Go ahead and predict. What will the moon look like in 3 days from then? And you can go ahead and use that Mentimeter bit.ly. You can find it in our comment section, or you can write down on a piece of paper what you think. We'll give you a little bit of time to think about it and then also let us know. What do you think? What will the moon look like in 3 more days?
The moon will still be there. I just moved it so we could only see blue, so we don't give it away.
All right, Josh, looks like we're getting quite a few ideas coming in.
I see some great ones.
Yeah, it looks like maybe smaller, or maybe a new moon, or maybe full moon.
Full moon, crescent, new moon, small, shiny. Very small. I like that. Invisible. So I've zoomed us way back. We can see where the moon is in the sky. Yep, I can't see that.
There we go.
I took my screen off. There we go. Now you can see where the moon is in the sky. It's getting closer and closer to the sun. Now I'm going to zoom us in. And when I do, you'll notice Venus is hanging out right next to the moon, which is always a cool thing to see. But check out the moon. Very different than what we saw before. Now we can only see that thin line of real illumination. And I think some folks said smiley face. That's my favorite name for this moon, is a smiley face moon, because it really does look like a smiley face just hanging out there in the daytime sky. Because the moon is relatively faint at this point and the sun is so bright, it can be tricky to see a crescent moon in the daytime. But if you've got sharp eyes and you know where to look, it is certainly something you can pick out. Now, one of my favorite things about the moon when it's in this part, and why I wanted to get it so close to Venus, is if you ever were able to point binoculars or a telescope at Venus, you can see it's got a phase too, which is always a really cool thing to see. Okay, zooming back all the way. If we waited a few more days, let's say 3 more days from this, what do you think it would look like? The moon has traveled away from Venus. We can see where the moon would be.
Looks like it's really close to the sun.
It is really close to the sun. And when it is so close to the sun, we call this a new moon. Until you get a nice bright edge coming out again, it's a new moon and is pretty much impossible to see from planet Earth. So it doesn't mean the moon's disappeared, doesn't mean the moon's exploded or gone away, the part of the moon that's getting hit by light is the part that's facing towards the sun. The part that's in shadow is facing towards us here on planet Earth. Okay, so we've seen a bunch of phases. Are there any questions?
Well, I'm kind of curious what the moon will look like after this new moon. So let's go ahead and hear from some of our scientist friends out there. What do you predict? What will the moon look like after the new moon? One second. I realized that I didn't switch over. So there you go. You should be able to now go ahead and vote.
I always think it's helpful to think about what the moon looked like first, and then how it changed, what it looks like now, and then move it forward a little bit and keep that change going.
All right. Some good ideas. All right. Looks like we have some ideas coming in.
Okay.
All right.
Crescent.
Crescent, maybe.
Bright.
Maybe starting to move to that full moon.
Let's check it out. Okay, so this was us on the 15th of November, so that's about a week from today, maybe a little more. And we went 3 more days. Let's go locate our moon. We might actually be bumping into a problem. Where's the moon? So here's the trick. We have to wait for our sun to get a little higher in the sky. And when it does, we should be able to see our moon come out. There we go. Let's give it some time. And pause. Okay. Now zooming in on the moon. What do you think? I would say that looks pretty crescenty. You've got that nice curving arc of light from the sun bouncing off the surface of the moon. Our moon is getting bigger. Our moon is becoming a crescent. It's getting closer to full. Do you want to try 3 more days?
All right, let's do it.
Okay. 1, 2, 3. Up again. We're below the horizon. Let me fast forward time a little bit. By a little bit, I mean a lot of bit. And we'll pause. 3 days after our crescent, we are getting close to a first quarter moon. Now, the first quarter moon is the sort of opposite side that we saw for the third quarter moon. It's getting more and more illuminated as time goes by, and eventually we will come all the way back around to that bright full moon, but it's going to take a little bit more time. So let's go 1, 2, 3, 4, 5, 6. That should get us pretty close to full. Maybe not quite there, but pretty close. Now we're getting close to when our moon is a nighttime moon. So once our sun goes down, we should see the moon rising. What do you think? Are we going to get it full?
It looks pretty close.
We're pretty close, but I'm not satisfied. I want to see a completely full moon. So that's going to be at least, I'm going to say 2 more days. Let's try this out. So let's go 1, 2. Okay. See if we have a full moon rising. Right over that tree. Oh, yeah. That's a full moon. So this hopefully looks like the full moon you folks saw just a couple days ago. We saw from those really cool observations. You saw a full moon at the end of October. What date is this? Very close to the end of November. So it turns out we should see a full moon just about every 28 and a half days. So every 28 and a half days, we go from full moon to full moon, from new moon to new moon, from first quarter moon to first quarter moon, from third quarter moon to third quarter moon. That cycle takes about 1 28-day period. Since that's very close to a month, astronomers like to call it 1 month.
That's a pretty good name for it.
Yeah, helps us remember.
Well, Josh, we were able to have some friends put some of their questions up on their on our Padlet a couple of days ago. And I wanted to kind of go through some of these
Hmm.
questions. Maybe take two now and two a little bit later.
Sounds good.
And they all happen to actually be about our moon. And so our first question is, why do we have a moon?
That's a complex question to answer, but I'm going to do my very best. So, Earth has a moon because a long time ago, we think we got bonked by a big object called, I think, Themis. So, the idea was that as our solar system was forming, a big object was forming at around where Earth was. A big object was forming a little farther away, and at some point, those two objects hit each other. The not Earth object called Themis was probably about the size of Mars. So that's a really big thing to get hit by. When we got clobbered, we formed a big blob of all the rocks that made up those two objects. And from that big cloud of rocks and metal and stuff, two objects formed. One was bigger and closer to the middle. That's Earth. And the smaller one, made of the stuff that was going around Earth, is our moon. So moon and Earth formed together from this giant debris cloud. So you could think of it as we're kind of like sibling objects. So that's, I
All
would
right.
say, why we have a moon is because we formed together.
All right. And then our other question is, how long does it take to get to the moon?
Ooh, so this is a interesting question because it's entirely dependent. The answer changes depending on how fast you're going. If I were to have a snail on a piece of string try and go to the moon, it would probably take a very long time. If I were to go on a rocket ship, it would take less time than a snail. If I were to go at the speed of light, it would take even less time. So for a snail, probably a really long time. I haven't done the math. For a rocket ship, like the Apollo ones, probably about 3.5 days to get from Earth to the moon. I almost knocked my coffee over. And for light, even faster than that, you can get from Earth to the moon, we say in about a second and a half, but it's actually about 1.3 seconds. So a really short amount of time.
I definitely want to be starting to travel the speed of light. That would be a
Yeah,
lot of fun.
not snail speed.
All right. Well, we got a lot of predictions down. Looking at our moon and our sun and how they move across the night sky, and I'm starting to see a lot of patterns. But that's only one perspective. That's looking at the sky and being on Earth. I kind of want to explore a little bit more of kind of going up to space. Now, before we do that, we need to remember that our Earth is a globe. And so we're actually going to pretend like we are Earth and think about how it moves in space. So to do this, if you happen to have that piece of paper, either of North America, South America, or maybe you drew one yourself, go ahead and grab that. If not, it's okay. You can pretend along with me and pretend North America is up here, South America is up here. We're just going to hold it up against ourselves. And we're going to pretend like our body is the world. We're nice and round. We're going to turn. And one thing we do know about our planet Earth is that it does spin or rotate, and it goes around the sun. And because of that, that's how we see the sun rise and set. And like Josh said earlier, we had the sun rising in the east and setting in the west. So with our finger, let's go ahead and show that path of the sun rising in the east and setting in the west. Let's do that a couple of times, just to remind ourselves. So I happen to have a marker here in San Francisco, so I know that's my west coast. And over here is my east coast, so rising in the east, setting in the west. Well, we're now going to pretend like, again, we are planet Earth, and we are going to see the sun. And to do that, I'm going to put our sun actually up on the screen. And we are going to try to move our bodies so that the sun right in front of us rises on the east coast and sets on the west coast. So we're going to move our bodies right or maybe left and rotate. So think about it. Where does your body need to be for the sun to start to rise? Is it like this? Is it like this? Is it straight on? Well, here's my East Coast, and I want it to start to come up on my East Coast, so I want to go kind of like this, so that the sun is just at the horizon. And now I need to move my body either this way or this way to have it start to rise, be nice and high in the sky, and to set in the west. So go ahead and try to move your body. Or is it this way? Do you turn around? Well, again, for it to rise in the east, I need to be facing this way. And then I want it to go nice and high in the sky. And then be able to set in the west. So this is the way I'm going to be turning around. All right. Well, Josh, now that we've kind of explored our own bodies as the or as the Earth, let's go ahead and blast off into space and see it actually in space itself. What do you think?
Okay, sounds pretty good. I think I am all set. So this hopefully looks a little familiar from what we were looking at before. Oop, I broke it. There we go. So you can see down here, we've got our same Golden Gate Park area. You can see our sun in the sky. The sun is at its very highest point, which we call noon. And now we're going to imagine taking ourselves off of where we were looking before and looking at the exact same thing from space. Pretty cool, right? And just like Jackie showed us, we're going to put a marker where we are in San Francisco. If your marker would be in a different spot, all you got to do is imagine it being in a slightly different location. And now we are going to watch Earth spin. So to do that, we are going to look at it from the side. We can see the side of Earth that's facing towards the sun, the side of Earth that's facing away. I bet you can instantly tell which side is facing towards the sun. It's the one with all the light on it. And if you imagine, just like you were spinning a second ago, a line coming out from the very top of Earth's head or from the very bottom of Earth's center, you would see a line kind of like this. Imagine if Earth was spinning on a string. We call these our poles. You may have heard of them before. There's somebody who lives at the North Pole everybody knows about. That's Superman. And down here, we have where Bizarro Superman lives at the South Pole. So, looking at planet Earth like this, let's imagine it spinning. It's spinning super fast. This is about 10 minutes a second. So just like you were spinning before, Earth is on the sunlit side, and eventually we're going to spin on to the nighttime side. As this is happening, you can keep track of what time it is. I can also show you the date we're seeing. So this is about a month ago. I think I set us 1 month too far back. But at October 6th, this is what our spin would have looked like. So as we're spinning, you can see right when San Francisco goes onto the nighttime side, the sun sets below the horizon, and we go onto the dark side of Earth. But are we going to stay there forever? Definitely not. As Earth keeps spinning, we will eventually come back to the sunlit side. We're going to fast forward, though, so we can see a lot of time go by quickly, and we're going to see what this looks like over the course of many weeks. Check it out. As we are spinning, that was a whole bunch of days. We're now about 2 months, almost 3 months later. You can see where San Francisco is. Now, it's really pronounced here. As we're spinning, you can kind of imagine us spinning around our pole. Do you think we're going to spend more time on the sunlit side or the night side? The sunlit side is actually going to be a pretty short path. The nighttime side is going to be a pretty long one. We spin at the same speed throughout, so we're going to spend a little bit of time on the sunlit side and a long time on the night side. And if you've ever thought about around December, our days are really short. Our nights are very long. We can actually tell just by looking up at the North Pole what season we're in. When the North Pole is completely in darkness and the sun never rises, that's when we're in winter. But are we staying in winter forever? Definitely not. Seasons keep changing, so let's advance by 3 whole months from this. I think we're going to go to March, super speed. Let's check it out again. Now, let's watch Earth spin and let's watch San Francisco move as it does. Are we going to spend more time on the sunlit side or the nighttime side? Trick question. We are going to spend an exactly equal amount of time on both, half in sunlight, half in darkness. And here's the really cool thing. That's true of every part of our planet. Way up here, Superman would see the exact same amount of sunlight as darkness all over Earth, northern hemisphere, southern hemisphere, down to even Antarctica, same amount of sunlight as dark. So these are very special nights we call equinox. Equinox means equal night. So equal day and equal night. If we go forward from spring, we can go all the way through to summer. And when we do, in summer, what do you think is going to happen? Well, if we check out here, it's kind of the opposite of winter. When we see San Francisco coming by, we're going to spend a lot more time on the bright part of Earth and a very short amount of time on the dark part. So we have long days and short nights. Now, let's check up with the North Pole, our friend Superman. When does the sun set up here? We could watch all day long, and we will never see darkness fall on the North Pole because in summer, the sun never sets in the Arctic. If we check the Antarctic, though, just like we saw before, the sun's never going to rise. It is in darkness 24 hours a day. So when we have summer in the northern hemisphere, we have winter down south. When we have spring in the northern hemisphere, they have autumn down south. We always experience the opposite season from northern to southern hemisphere, which is super cool. Okay, but I'm going to take us back to the present. Here we go. Or at least a month ago. I messed up again. And now let's check this out, because it's not just Earth that's spinning. We also saw our moon moving before, and I want to check that out too. So we're going to take a big fly backwards because I want us to be able to see the orbit of our moon. Can you see it there, that big blue line? And now let's try this. We're going to make Earth and the moon bigger so we can see what phase they're in. Here we go. That is a giant Earth and also a giant moon. So let's try this. If we were looking at the moon from Earth a month ago, we would see something kind of like this, with the moon partially lit up, a little bit of crescent right there. So if we wanted to see our moon change over time, all we have to do is wait a couple days. Let's say 3 days, just like we did before. 1, 2, 3. Okay, 3 days in the future, our moon went from a crescent. I would call that a first quarter. And if we go 1, 2, 3 more days, ooh, that's looking like maybe a gibbous moon. Try 3 more days. 1, 2, 3. And now, if I look at the moon from Earth's perspective, I would say we are getting pretty close to a fully lit up moon. And if we wanted to check to see if this is a full moon, we just have to see if it's opposite the sun. So when the moon is opposite the sun, that's when we know we have a proper full moon. It looks pretty close. Okay. Now let's try maybe 6 days, speeding up super time. 1, 2, 3, 4, 5, 6. Okay? And what do we have here? I'd call that a third quarter moon, right on schedule. And let's try 6 more days to see if that gets us to a new moon. Are you ready? 1, 2, 3, 4, 5, 6. I think I'm a little short because we're not actually on a, what would that be, 24 days? We would need 28 days, so I need maybe 4 more. Let's split the difference, do 2. Now, right now, the moon is between us and the sun. If the moon was actually this big, we'd probably have a solar eclipse, but the moon's actually much smaller. Remember, we made it bigger so we could see? And because of that, We just don't see any light coming to us from the moon. That's what we call the new moon. To get us back to where we started at that thin crescent, all we got to do is fast forward again just a couple more days. And all of a sudden, 1 month after we began, we are back to the exact same spot with a thin crescent moon. Okay, do we have time left, Jackie, for our final bits?
We are definitely getting a little bit over,
Okay.
and I want to go ahead and have the opportunity for students to actually explore this a little bit on their own first. There are lots of activities that we have planned for you, and one of them is to kind of look a little bit closer at the Earth, and kind of looking at those seasons again in a different
Mm-hmm.
perspective. So if you have a chance, definitely check out our student website. And we have some fun activities. Again, more creative writing, which I truly appreciate everybody who sent in your constellation myths. That was awesome to read. Also thinking about packing for a planet. For
For
next
next
time, we will
week.
be
Yep.
exploring some planets other than our own. And then also, you can explore your own night sky with the software that Josh used earlier today, Stellarium. So there is a link there. And then also checking out those seasons by watching a video that we happen to have here at the Academy. So I'm kind of excited for what is going to happen next week. And so I know our time is up, but Josh, do you have maybe like a couple more minutes to answer maybe
Absolutely.
2 more questions?
Let's check it out.
All right. So if you all have to go, that's okay. You can take off and maybe come back to the recording to hear the answers to these questions. All right.
Let's
So
see.
Josh, we had 2 more questions that came up. We had, if and when will the moon become dust slowly, really slowly, and disappear?
So, eventually in the universe, a lot of particles will break down, and you could say, okay, maybe the moon will become dust, but that's a really long time. We're talking about trillions, hundreds of trillions of years. I think what I would say is more likely to happen sooner. Our moon is actually moving away from Earth. So it's not going to turn into dust as a whole object. It's going to drift away from us and eventually escape off into our solar system. And some
Hmm.
people think of that as sad, but it's just physics. It just happens. But if you wanted to calculate how far the moon is traveling away from us, there's actually a really cool way for you to keep track of it. Because the moon is moving away from Earth at about the same speed that your fingernails are growing. So if you think about how fast your fingernails are growing, over the course of 1 year, if you never trimmed your fingernails, they would get pretty long, right? Maybe about half an inch, 4 centimeters. I don't let my fingernails get that long, so it's hard for me to tell. But if I let my fingernails grow, maybe for a couple years, they would get pretty long, and that would be about how far the moon's moved away from us. So
Interesting.
it's not going fast. It's going, but it's not going very fast.
So not within our lifetimes and maybe a couple more generations.
I think a long, long, long time.
All right. And then our last question came in is asking, can we set up a moon base? Is it possible to live on the moon? And if so, why haven't we actually done it yet?
So, can we set up a moon base? We set up small ways for humans to survive on the moon back in the late 60s, early 70s with the Apollo missions. And ever since then, there's been people thinking about what would it take to do that again or to maybe make it a little bit longer term. And right now, we're looking at the Artemis missions being developed by NASA and a bunch of other collaborators. But they are coming up with ideas to land habitats on the moon that could really stay there for a long time. So, when my family goes camping, we tend to do it in 2 different ways. Either we go car camping, where you park someplace, you throw your tent out, and you hang out there for a night or two, and then you go away. But sometimes it's nice to go camping for a little bit longer. You set up a bigger camp, you hang out, you kind of make the space yours for a little bit longer. That's what we're getting ready for as explorers. We want to go someplace and stay there for longer, get a little bit more comfortable, and learn more about it. So we are working on the technology. We can survive on the moon. We are pretty sure. We did it before. We're getting better and better at doing it. And we think there's water on the moon that we might be able to make use of, turn it into hydrogen for rocket fuel, oxygen for us to breathe. Could be a really useful supply. And the last part of the question was, why haven't we done it yet? Money. It turns out Visiting space is very expensive. It takes a lot of American tax dollars to do. I think it is one of the coolest things we can do with our tax dollars, but there's a lot of important things that we spend money on as a government, and space is just one of those factors. But if you ever want to imagine how much money we send from every dollar of our taxes to NASA, here's a cool way to think about it. If you took $1 bill and chopped it into 100 pieces, little tiny pieces, itty bits, then from those 100 itty bits of a dollar, take one of them and chop it into 10 pieces and take four of those, that would be how much NASA gets of every American tax dollar. So between, I think it's either it'd be 4/10 of a cent. So there's a lot of things we spend money on. NASA is just one of them. There's a lot of ways we spend this money, and if you ever want to encourage your senators or government officials to spend more money on space, I think a lot of space scientists would appreciate it. But thanks for asking.
Yeah, it definitely sounds like some of our friends are interested in going to space themselves. So that's one way of doing it. All right. Well, we want to say thank you, everybody, for joining us and exploring along with us our sun and moon. And I'm really excited that next week we will be packing for a planet and thinking about some planets and visiting them. But for those of you who are still watching, you can go ahead and give us some of your feedback if you would like. Also, this is a place where you can put in your questions, and we'll be able to bring some of those questions back into our session next week. So thank you, everybody. Have a great rest of your day. Bye.